Howdy everyone, Mr. Causey here with another problem of the week, and this week we're going to look at molarity. So let's get right into the problem. Calculate the molarity of a solution prepared by dissolving 16.45 grams of ammonium nitrate in water to make a 250 milliliter solution. Now what we want to notice here is this is a molarity problem, and the first thing you want to do is make sure you know what molarity is. And molarity is the moles of solute per liters of solution. Now note that that's solution, not solvent. Then once you know what molarity is, or you're sure you've got your molarity equation, what you want to do is create a plan. So first we want to determine the moles of solute, which also means we're going to determine the molar mass of ammonium nitrate, and we'll use the molar mass to calculate the moles of solute. And so be sure you get out your periodic table. Then we'll determine the liters of solution, and then we'll plug and chug. Well, let's go to the magic board and let's calculate the molar mass. First of all, we have our ammonium nitrate, and we want to note here on the ammonium nitrate we have 2 nitrogen, and if you look on the periodic table, nitrogen is 14.0, and so 2 moles times 14 grams per mole. Then notice we have 4 hydrogen and we have 3 oxygen. Now that means we're going to take and write these all out and add them up. We have 28 grams per mole. That'll give us 4.04 grams per mole, and that'll give us 48.0 grams per mole. Add them up and we have 80.0 grams per mole, and I'm going to use 3 sig figs in this situation, or to the 10th place, and let's go to the next step. Moles of solute. Now again, ammonium nitrate is 80.0 grams per mole as a molar mass, and if we take the number of grams that we're using of solute and multiply that to the conversion of 1 mole per 80 grams. Grams will cancel out. And you see how unit analysis, or maybe you call it dimensional analysis, is useful. It's very useful for helping us figure out which way to put our conversion. We want the grams to cancel out. Now that's going to give us 0.2056 moles of ammonium nitrate, and I'm not going to use my sig figs and round off at the third significant figure at this point, because that would introduce error, and I'm not ready to be done with the problem yet. So I'm going to wait until after we've done our final calculation to do the sig figs on ammonium nitrate. Now let's do the liters of solution. 250 milliliters is the same as 0.250 liters. We need to make that conversion to liters in order to work in the equation, because remember the equation is moles of solute per liters of solution. Now it's time to go to the molarity. Notice that we have our 2 quantities and 0.2056 moles per 0.250 liters. Put that in, plug and chug it, and we get 0.822 moles per liter, which is the same as 0.822 molar ammonium nitrate. Alright, let's recap. You determined the molar mass, you calculated the moles of solute, you determined the liters of solution, you then calculated the molarity, and you had a great problem. As always, if you have any questions, send an email to Mr. Causey at mrcausey.com. Check out my website for more PowerPoint videos and much, much more. And if you want to get more of these, be sure to join my YouTube channel. Alright everybody, happy ions.